Now, remember when we did parts and we talked about keeping them symmetrical? It really does depend what it is you make and whether it needs to be, whether it's as important in terms of assemblies. But you can get to a stage where you connecting an assembly to another assembly to another assembly, and you have whole trees and hierarchies with different assemblies. So it is still good practice to put assemblies or make them symmetrical where you can. Okay. So what I'm going to do, I'm going to turn on our planes by right-clicking them under Origin, right-clicking them and going to Visibility and just selecting it. Okay. And you'll see that our origin planes come on, and our origin is this point here. Okay. So what I want to do is I want everything on this box to be symmetrical, because it will just make it neater and it's just good practice. If you're doing simple models at home and it's just for hobby use, you don't really need to worry too much about it, but it is good practice, and if you did go into the industry you would be expected to do it that way. So I will just demonstrate it, and it's up to you if you go to that degree, but like I say, it's good practice. So all you need to do really is work out a length. So we know that's 400, okay. So then you can constrain, and that is the correct face. So we could constrain, we could make this let me demonstrate this actually. Actually, this would be a good way to demonstrate offsetting constraints. Okay. So we know this length here. Let me just go to Tools and Measure. This length will be 400, okay, of our box. So if I was to constrain and make this face flush with our origin plane in this direction, okay, well that's not really put it in the center, it's put it on the end. So what we want is we want the plane to be through the middle of this box really. Okay, so when you use these constraints, even though it's a flush constraint, it doesn't actually need to be flush. Flush is just the basis of setting something out. We can actually move this into the center, and this is something you'll do a lot. You'll use constraints, but then you'll give them an offset from that constraint. And that's another thing that sounds a lot more complicated than it is, but this is something you'll do all the time. Okay, so in order to get our part, the center of our part on this plane, well, look, we know the distance is 400 and we have a flush constraint on this end. So what we need to do really, we need to be able to say, I want this to be flush, this end to be flush with this plane and offset by half the length, which will be 200. Okay, well we can do that. We can select our part, which is highlighted here. If we click on the arrow, you'll see you get these mate, flush, flush. This is actually a list of all the constraints in the drawing related to that part. Okay, so if we click on mate 1, you'll see we get two different types of blue or purple light up, and that is showing, okay, this mate constraint, it relates the face of this part to the face of that part. So we know that mate constraint was when we joined the end of this to there, because it's highlighting the two surfaces. Likewise, if we click on flush 1, it's highlighting these. We made this face flush with that one. Flush 2, it's showing us these two top surfaces. So we can see what our constraints were. Okay, and flush 3 is our face of here onto this plane. If you double click a constraint, you'll see it asks for a dimension. Well, why would you need a dimension on a constraint? Surely flush just means put things flush. Well, this goes back to how we can edit constraints to work for us. We know half the length of this is 200, so if we put in 200, okay, we can see our part is now, it's moved away from the plane. Well, it's moved away 200 millimeters. Okay. In our case, we wanted it to move in the other direction. That's not a problem. All we need to do, if we double click that again, is put minus 200. And you can see now that what it's done is it said, okay, this face will be flush to that plane minus 200 millimeters. And because this is 400 millimeters, it basically put it in the middle. Okay. I do get that probably sounded 1,000 times more complicated than it needed to. It's one of those things, I'm trying to explain it and break it down. Just doing it should make it all be clear. Okay. If you didn't quite grasp what I'm saying, just bear with us. We're going to do it so many times it will just become second nature. And I'm going to do it again now. Okay, so we go assemble, constrain, and we need to look at this because on this side of the box we will have 300, but we'll also have this 10 millimeters here, and again on the other side eventually. So that will actually be 300 plus 10 plus 10, so 320. So we want to do a constrain on this side with the extra part, and that, and we can type it straight in here. We don't need to do it and then bring it back up. That was just to demonstrate we can type the distance straight in this offset box. So let's go minus, so it's 320 divided by 2 is 160, and there we go, minus 160. Okay. So now, these two parts, because we've done that offset constraint, these are centralized. It is sitting on this plane, so just to make things neater, let's move this up as well. We know this is 100 millimeters deep, so it'll be a simple constrain, and you can work through these planes like I'm doing here. You can see your face is highlighting green, so you know you've got the correct face. In this case we could use either of these two. I'll use this one. So we want that to be flush with that work plane. Now, you see this green arrow when we select, let me show you that again, when we select the face you'll get a green arrow, and it's kind of telling you the direction. Okay, so if it was a flush command, you'll see these two arrows are facing the same direction. That means that's because they're flush. Okay, if we selected that and then our plane here, it's not really flush, it's more of a mate because they're facing different directions, so it's almost like they're stuck together. So in this case, instead of using flush, we'll use a mate command. Okay, if the arrows were pointing in the same direction, it'd be a flush because it'd be, the surfaces will be flush, as in facing the same way. When the arrows are pointing in different directions, it's a mate command. And you can see that demonstrated here. If you get confused, it shows it. Again, this is something that sounds way more confusing than it is, and it will become second nature. But we're going to put our offset here of half of this, so that will be 50. And we can see, when you have you get these glasses here, these spectacles, and that means it's going to preview everything. So if I put that back to 0, you can see it moves. Okay, and what we want is minus 50. There we go. If you don't have that much of a powerful computer, you can turn this preview off, and all that means is you have to OK it, and if it's not very good, just undo it. Okay, but it does help you out if your computer's good enough to have this turned on. It's worth having it on so you can see how these commands react. Okay, so I'll apply that. And we can close that window. And if we look at the sides of our box, it's now completely symmetrical around the origin planes. So that is good practice. It also means we don't need to really do as much work now. You might have been wondering why I've only done one of each side. Well, we can just use a mirror command now. In assembly we have mirror command, and it works just like the mirror command on the part building.